Now let's continue another interesting debugging practice. In this debugging practice, I'm going to modify the bit flag inside machine exception delegation register to see how it affects control flow of exception. For this, the first thing I'm going to do is to go back to the state before running ECALL assembly instruction in supervisor mode. For this, I will use r.undo command. Please look at this. This is a TRACE32 command. Now, as you can see, the privilege mode is supervisor mode. Now, software is running in supervisor mode where Linux kernel is running. This is the API in Linux kernel. The name of this function is SBI get markid. So before running this assembly instruction, I'm going to modify the bit flag inside the machine exception delegation register. So as you can see, there are the several bit flag inside machine exception delegation register. Among many of the bit flag, I will change the 9th bit position because 9 is the exception code when ECALL assembly instruction runs in supervisor mode. For this, I will choose this icon to modify the value again. As you can see, 9th bit inside machine exception delegation register is 1 at this moment. For better understanding, so let's look at the table that describes the exception code. As you can see, 9, please look at this, 9 is the environment call from S mode. So this table comes from this RISC-V reference manual. So I will go back to the TRACE32 debugging program. Now I will run this assembly instruction again. Since this bit is the 1 in this case, so exception will be delegated. This type of exception will be delegated to the supervisor mode instead of machine mode. What I mean is, even though ECALL instruction runs in supervisor mode, but in this case, privilege mode does not switch because this type of exception, that is, environment call from supervisor mode, is delegated to the supervisor mode. Now, I'm going to run this instruction. So please pay attention to this icon. This icon indicates the privilege mode. That is the address of program counter. So here you go, 1, 2, 3. Please take a look at this. Privilege mode does not change. At this moment, trap handler is handle exception at this point. Handle exception is the trap handler in Linux kernel. So at this time, privilege mode does not switch, only moving to the trap handler in Linux kernel. Name of the trap handler in Linux kernel is handle exception. So this label is available under arc, RISC-V, and kernel entry S. So if you visit the website of Linux kernel, and you're going to see how this label is implemented. So important point is, at this moment, you're going to see that privilege mode does not change. Only the program counters move to the trap handler in Linux kernel. Name of the trap handler is handle exception. So this shows that the machine exception delegation register can affect control flow of environment call from the supervisor mode type of the exception. Now we're going to perform another interesting debugging practice. For this, I will use r.undo command again. Let's look at this. Okay, we come back to the previous state before running ECALL assembly instruction. Now at this moment, I'm going to modify 9th bit inside machine exception delegation register from 1 to 0. Now please take a look at this. 9th bit of the machine exception delegation register is updated to 0. But at this moment, this type of exception is not delegated to supervisor mode. Now, let's see what is going to happen. So I'm going to click this icon. Please look at this. The privilege mode switched from supervisor mode to the machine mode. And point counter is jumped to the trap handler in OpenSBI. In summary, this debugging practice will show you how the machine exception delegation register could affect the control flow of each type of exception. So when you bring up the RISC-V based device, so it is necessary to review the value of machine exception delegation register as well as machine interrupt the delegation register, because it is important interface to configure the control flow of the interrupt and exception.